In this video we discuss how a confounding variable can influence the results of a statistical analysis, and we will discuss two methods to counter the effect of confounding variables. One is a more classical method, is called covariant analysis. The second method is more recent, it's called multi-level analysis. So let's start by introducing the data set. So the first column is the dose. It's a value from 1 to 3. It indicates whether no, a low or a high dose of Viagra was administered. The second column is the dependent variable. It's a measurement for the libido of the participant. And the third column is a possible confounding variable, which is the libido of the partner. And the latter two columns just code whether it's a low or a high dose. So let's read this file. Again, the example is from the book from Andy Field. And it's called Viagra covariant. So classical analysis, we would look at the effect of the libido, of the dose on the libido. So if you look at the results and look at the confidence intervals for the difference, we see there's no significant difference between 1 and 2 and a marginally one between 1 and 3. Another way of looking at it is we could compare this variable pattern to constant pattern, and we see that the AIC even goes slightly down, so there's hardly any difference between a model for which the average libido varies with the dose and a model for which it is constant. So actually the evidence ratio between both models is 1.1, which means they're actually the same. The traditional way of reaching a similar conclusion would be doing a one-way ANOVA, and then the F-test would say that there's actually not significant evidence to conclude that there's a variation in libido. Now the reason why there's no variation could be that the confounding variable which might be there, which is the partner libido, might not be evenly distributed over the three groups. Suppose that the libido increases with the partner libido and that the average partner libido is lower in the group that was administered a high dose, then that could be a possible explanation why no effect is shown. Now, a traditional way of countering this is through covariant analysis, and we will show how to do this in ILLMO. The way to do this is to read the same data file again, but now look at individuals rather than groups. So we read the same file again. And now we treat the individuals as cases. And so the variable is still the libido, but we take the other independent variables with us. So what covariant analysis proposes to do is say that let's remove the effect of the partner libido by doing a simple regression of the partner libido versus the participant libido and saving the residue value. So we'll create a file. And we save the both the model, data, the model, and the residue values together with the variables that we haven't used yet. So we go back to our original analysis of the versus the dose. So we read the file that we just created. And now we use the dose as the condition, and instead of using the data itself, we use the residue, so corrected for the influence of the confounding variable, and we So what we see now, if we that there's a small change in the sense that, okay, both differences are now significant with the case where there's no Viagra administered, both the low and the high dose, but there doesn't seem to be any difference between the low and the high dose. So this traditional covariant analysis does something, but not very much. Now, this traditional analysis is based on the assumption that the influence of the confounding variable is the same for all three groups. That is called the assumption of constant slope, and traditional statistics says you have to check whether that is the case. So let's check whether that is the case. And again, read the data, but now yet in another way. So again, the same data. We still read individuals. But we consider the dose as a selection variable. So that means we will split the data set into 3 parts depending on the dose. And we will include the other independent variables. So there's now 3, and for each of them we can do the connect to the confounding variable and look at versus what the gain is. So we make for each of them after which we can look at the overview and look at the gain. And we see that the gains are not, so the relationship between partner libido and libido is not the same in all cases. For the first 2 cases, so no Viagra or low dose, we see a positive slope, so positive influence. But for the third group with a high dose, we see no significant influence of the partner libido. So that means that the assumption of a traditional covariant analysis is not valid. So how can we handle this case? We again save this results of the analysis, but we now save them for the entire group. So we're going to create a second file. We're still going to say the model values. And we say we remove the confounding variable and we include the dose and now let's see if we look at these new residues which now have a different correction for the confounding variable for each dose condition, and try to read that file. So the residue value is the dependent variable, the dose is the condition. And if we look now to the data and make the difference intervals, we see both a significant effect between low dose and no dose, and a significant effect between high dose and low dose.